So at this point, we're going to switch to a different view so you can see me working with tables and graphs and finding that unit rate or rate of change or slope. When we look at a table, a lot of times we actually refer to slope as the rate of change. And what we're looking for is our change in our y value or our independent variable and our change in our x value or dependent variable to independent variable. So if we talk about our ratio of change in y to change in x, then what we're looking for is our change in y to put in the numerator and our change in x to put in the denominator. So looking for our change in y, we just look for the difference between these two amounts. You can think of it as what number do I add to 0 to get to 40? And then what number do I add to 40 to get to 80? And what number do I add to 80 to get to 200? Now this one's a little different, isn't it? That's 120 that I'm adding in. So these are the amounts I'm adding, or these are my changes in y. So let's go over and look at our change in x. From 0 to 2, I'm adding 2 to go make that change. From 2 to 4, it's plus 2 as well. But from 4 to 10, it's actually plus 6. It's really important when you're working with your students that you have them make these changes not always uniformly. They need to understand that we're looking at our ratio of 40 to 2, 40 to 2, and 120 to 6. And when we look at those, you actually see that those ratios are constant. This is our constant rate of change. All of these ratios simplify to 20 over 1. And since the ratios are constant, that means it's a linear function. And we have what is our change in y over change in x, which is our slope. Let's look at another one. In this one, again, we're looking for our change in y, or our change in our dependent variable, to our change in x, our change in our independent variable. The ratio of the change in y to the change in x is our slope. So we look at our first number and our second number and we say, what do we have to add to go from 20 to 40? What do we have to add to go from 40 to 80? And what do we have to add to go from 80 to 200? We aren't done yet because we need to check our changes over here. Oh, I see. Change 40. From 1 to 2, plus 1. From 2 to 4, plus 2. From 4 to 10, plus 6. And now we're going to look at our ratios of our change in y to change in x that match up. So we have 20 over 1, we have 40 over 2, and we have 120 over 6. If we simplify these ratios, we see that each time we have equivalent ratios, which are all simplifying to 20 over 1. So our slope in this situation is again 20. One more. I added in some negatives just to make it fun for us. As we do our change in y's, we look at what we add or subtract to go from this number to this number. So in this case, we're actually subtracting 8 to go from 9 to 1. To go from 1 to negative 5, that is a difference of 6. And to go from negative 5 to negative 15 is a difference of 10. We're actually subtracting 10 to make that change. We'll go over here and do our change in x. From negative 2 to 2, we have to add 4. From 2 to 5, it's a plus 3. And from 5 to 10 is a plus 5. And so now we're going to check our change in y to our change in x ratio, which should be our slope. So we have negative 8 divided by positive 4. We have negative 6 divided by positive 3. And we have negative 10 divided by positive 5. Now if we simplify each of these ratios, we'll end up with negative 2 each time. So these ratios are equal. The table's demonstrating constant rate of change. Each rate of change is the same, so we know it's linear. And our change in y over change in x, our slope, is equal to negative 2. Make sure that you do just what I did and let your students see different rates of change for x and slopes that increase and decrease, like this one.